I'm delighted to welcome Mark from SMD, who are one of the region's kind of shining lights in terms of innovation and building amazing things. And I'm hoping that Mark is going to tell us about some of those amazing things, amongst other things. So, Mark, can I hand over to you?
Yes, you can. Yes, thanks, Terry. Right, I will now try and share my screen. Can everybody see that screen? It says Subsea Robotics.
We can still.
Oh no, here we go.
Oh, yes, here we go. Yes.
There we are. Right. Right. Okay. So, yeah, I'll just dive right into it. I'm going to talk about Subsea Robotics, give you a bit of a flavour about what we do here in the Northeast. I work for a company called SMD, and we are a robot manufacturer. Been around for 50 years. We're celebrating our 50th birthday this year. We've got about 250 staff. We have offices in Wallsend, and we also have offices in Shanghai, in Houston, and in Brazil. A little bit about myself. So I'm the director of remote and autonomous systems. It's a bit of a grand title, but essentially I started my subsea career in the 1990s. I've always been in the subsea industry when I came out of university, and I've spent 25 years designing and coming up with new products for the underwater world. And that's always been around sonar systems and underwater vehicles, as we call them. And I'm currently responsible for delivery of SMD's next generation of subsea robots. So, as we speak right now, there's robots operating in the world's oceans. They're operating across all industries. So primarily they're used in the oil and gas industry, but more recently they've been starting to get used in offshore renewables and wind farms. And you can see the scale of these wind farms in this picture here on the left-hand side. They are used in defense. You quite often don't hear about those robots for obvious reasons. Used a lot in science as well. Science tends to go very, very deep. It's very difficult to get humans down that deep, so they have to rely on robots. Some interesting places where you may have seen them, because it does attract television reporting, is on salvage and exploration. And down here you can see a robot which is serving the Titanic. That's Titanic, which sits in, I think it's about 4,000 meters of water. It's very, very deep. And this robot here is a mine hunting robot. Clearly robots are preferred to go looking for mines rather than people, because if there is a problem or the mine explodes, then it's only the robot that takes the hit. So used across a lot of industries. So what types of robots are there? Well, you actually get really small to really big. The first type is called the light observation robot, OBSROV, as we call them. And you can see here, this one fits into the palm of your hand. They go up to about maybe 50, 60 kilos, and they tend to be used for support roles or for inland work in dams or lakes or very near to the shore. The next type of robot is this one over here. It's called an AUV. These are untethered flying robots. So these tend to look very sleek. When I say they fly like an aeroplane under the water. And they are programmed, and they can travel hundreds of miles. So when you hear about companies exploring underneath the ice in the Arctic or the Antarctic, it's these type of robots that are used. And they're primarily used to gather data and report back. When they come back, the data is downloaded, and the scientists can get a feel for what's actually happening. The next robots, and this is the ones that SMD specialize in, are quite large, and they tend to be the working robots. So this here is what we call a work class robot. It is the work person of the sea, very widely used, and I'll talk a bit more about them shortly. And then finally, you get the real monsters. This is the heavy seabed intervention machines, and this is where SMD actually started. When SMD came out of Newcastle University back in the 70s, it was Professor Rees who came up with the idea of a subsea plow. And this is a subsea plow here, and you can see a man standing next to it here. And this is what's used to plow the seabed to create a trench for putting in cables and pipelines. But I'll talk about that in a minute. The robot you see next to it is a subsea tractor. It is part of the self-propelling robots, which do a similar job. So what do they do? So the small robots, the OBS ROVs as we call them, they go down and have a look and they survey. So they're used extensively for inspecting the hull of a ship. So when ships are crossing the seas quite often, they will pick up marine growth, and that marine growth needs to be cleaned off. It needs to be inspected. Also, as well as if there's any damage, they need to get down and inspect it. They can do it with divers, but if it's a busy port, quite often they don't want to use divers. So they'll use some of these small robots that can be launched by hand, throw them over the side, and they can get an inspection of the hull of the vessel. They're also used in dam inspection, and they're also used by police and fire services for inland waterways, for finding items discarded in a crime or whatnot. When you start going much deeper, and going to look at the Titanic, for example, you start to use the bigger robots, and this is where the work robots come in. Now, this robot down here on the bottom left is a robot SMD supplied to MBARI, the Monterey Bay Aquarium Research Institute in California, and it's used for very deep ocean observation and survey. And they will go down and they will find new species, they will find new fish, they will take samples. And you can actually see in the robot's hand here that it's got, quite hard to see, it's got a sampling tube, and that's used for pushing into the sand and taking samples of the deep sea floor. This device underneath the robot is what we call a toy box, and that has lots of other tools in there that the robot can use when it's exploring. More recently, there has been robots designed to actually start mining the seafloor. The seafloor is rich in minerals. Some of those minerals are just sitting on the seafloor, and there has been SMD has actually pioneered the designing of machines to gather these minerals, to scoop them up. Really widely used are these two here, and this is where SMD specializes in the robots, and that is to either maintain infrastructure subsea or install infrastructure subsea. So this is the work class ROV here, and it is interfacing with a subsea oil well. And then down the bottom right here, we have the trenching robot, and it is used to put the power cables in between the wind farms, and then also to bring those power cables back to shore. Okay. So when we talk about subsea infrastructure, what do I mean? So some people don't kind of realize there's lots and lots of technology across the world's ocean floor. On the left here, this is an oil platform, and what we call an FPSO, and it is usually connected to the seafloor with its legs. But actually, underneath there is a whole city of technology that can control the flow of oil and gas, that can monitor it, that can do all sorts of things. And this technology can be maintained by divers, but actually, as it gets deeper, you cannot use divers. they tend to use the robots. Also, there are safety implications with using divers. People don't tend to use them as much as they used to. And you can actually see a little robot in this picture here with its light shining, coming down to one of the subsea assets. On the right-hand side is a really interesting picture. This is a picture of the subsea cables that crisscross the world's oceans. Now, some people may have heard in the news over the last couple of years, last year, I think, that the UK government was very concerned with Russia possibly disrupting the subsea cables into Europe. And this is what they meant by that. You can see between America and Europe here, there are a huge number of cables that literally run, like the wiring in your house, from different points in Europe to America. And those cables, they carry data. They can be power cables. They can also be pipelines. That's not shown there. But when you make a phone call to relatives overseas, you don't do it via satellite. Your call will carry through fiber optic cables under the sea, primarily. Every now and then you do use a satellite, but primarily it's subsea cables. And it's incredible. All the internet traffic goes through these cables. So you can imagine if they are disrupted, there's a real big problem, really big problem. You can isolate nations by disrupting the telecommunication network. So this is the infrastructure that needs to be maintained. It needs to be protected. And this is the type of equipment that SMD builds to maintain and protect that equipment. This picture up here is landfall of a pipeline or a cable. So if you're walking on the beach at Camas or at Blythe, you sometimes see these pipes coming up from the sea. Can be cables, it can be pipes, and the other end of that could be in Holland, or it could be in Norway, it could be in Iceland, it could be anywhere. It's a good example of these cables coming in. So when we talk about a working robot, let's just look at the anatomy of one. So this is one that SMD specialize in. It's about the size of an SUV. So it's about 2 to 5 tons in size. And because it is the equivalent of somebody who will come around to your house and fix things, or a car mechanic, it has some similar features to what a human will have. It has ears in the form of sonar systems. It has a head and eyes, which in the form of panatilts and cameras and lights, and they move just like a human head. You can look at different things. You can tell the robot to look at things. They have arms, which look like arms. Now, these arms tend to be quite large and powerful, these robot arms. They differ quite significantly from a car manufacturing robotic arms that you'll see at Nissan. They tend to be stronger, a bit more robust, because these arms take a bit of beating when the robot's under the sea. But a typical arm like that has about a 250 kilogram lift. So it'll be able to lift a motorbike up, no problem. Pretty powerful arms. And the hands that are on the end of the arms, they're very dexterous. They're very flexible. They can hold a variety of tools, and they can be very gentle, or they can be very powerful. And the operator has full control over that. Within the body of the robot is where we carry the payload. And the payload is the tools. And the tools depend on what job the robot is doing. So you can have a robot do a cleaning job. So remember I was telling you about a ship may have lots of barnacles on it. A robot may go down with a jetting system that jets off these barnacles and cleans it up. It can go down with instruments to measure the amount of corrosion. It can go down with all sorts of different instruments, grinders, cutters, drills, whatever. The robots themselves are propelled through the water with what we call a thruster. And a thruster, it's just like a boat propeller, except a low speed, very high torque units. And we have a number of these on the vehicle, and they all point in different directions. And the reason for that is these robots don't fly like an airplane. underwater. They fly like a drone, okay? And that means they hover. They can move in any direction, and they have to also counteract currents. Now that's very different from being on a drone, for example, because we don't have gravity to deal with under the water. So the robot is not always wanting to sink like a drone does. A drone has its propellers mounted on the roof of the vehicle to counteract gravity. What we need more force on the horizontal plane, because it's primarily counteracting currents. Now, if anybody's walked through a river, even that's just up to your knees, you'll know how powerful water can be. Quite often, if a fast-flowing river can sweep you off your feet in not very deep. So these vehicles need to be very powerful and be able to counteract that and then remain in control. And we can position these robots within less than 5 centimeters in currents up to 1 to 2 knots and hold them there for indefinitely. So moving on to the challenges that a company like SMD, who are a manufacturer of these robots, what are the challenges that we see going forward? A lot of people say to us, how do you make it waterproof? And, oh, what about the pressure? You know, these are not really challenges now. We've overcome those with over 50 years of doing robots. That's not really the main challenges. The main challenges come down to these 3 bubbles, really. And it's cost around how we support and deploy these robots, the reliability of these robots, how fast they can do a task, how effective they can do a task as well. Environment, legislation is changing all the time, and we need to reduce the CO2 levels, and these robots are no exception to that. They have to be able to meet with the latest legislation and actually do their bit for the planet as well. And then the final thing is accessibility. These robots up to now have been run by companies who are very specialist, and they have to have all the infrastructure supporting them and the people and the training to be able to run them. And what we're trying to do going forward is to try and make it more accessible, so more people and more companies can get access to this type of technology to go and be able to do what they want to do with the world's oceans. So as an example, when we consider the cost and the environment accessibility, currently all these robots need a support vessel. And you will have seen these coming into the time, you know, and if you've ever stood there watching these vessels, they're pretty big. They're pretty big vessels. This vessel down here on the left, that is an offshore construction vessel. It has a garage. You can see the garage door here that opens. The robots are deployed off the side of it. And then on the back, here's a crane, which is used to possibly lower and install subsea equipment. Not always used. Sometimes these vessels are just used to deploy the robot for inspection, repair, and maintenance work. This is how they're often deployed off the side of the vessel using what we call an A-frame launch system. There's different variations, but this one's very common. And you can see the man standing there watching the robot get lowered off the side. And these can grow. When you start to look at the big trenching vehicles, these are massive pieces of equipment, and they need massive vessels. They're very, very large. So why do we need the support vessel? Well, actually, they provide a job of getting the equipment to site. They provide the logistics. The work can be anywhere. It could be a few hundred meters from shore, or it could be thousands of miles in the middle of the Pacific Ocean. So you need the vessels to get to site. They're also used to house the experts, the guys who will run the robots, maintain the robots, analyze the data. There's also laboratories on board, lots of other things. And this picture up here on the right, top right, shows a ROV control room. And there's quite a lot of people in this control room, all staring at the video screens that are transmitting the pictures back from the robot and what it is seeing. These screens also show sonar images, which are used extensively subsea, because quite often you can't see very far if the waters are murky. So you rely on advanced acoustics, which can give you a fantastic picture of what's happening. And this guy here, he's actually controlling the robot with a joystick. So he's actually flying it manually on there. Once you've got to site, they provide the launch platform, which you saw on the previous slide, and there's another type there. And that means that the vessel itself can sit above the work site, holding station. These vessels are also very powerful. They can hold station when the waves are very high or when the currents are very high above the work site, so the work can be conducted. And then finally, they're used to power the robots. Now, the robots, the smallest robots we make are about 100 kilowatts of power, still a reasonable amount of power. You don't get that in your house. Up to megawatts of power for the trenching machines. And that's huge amounts of power. Power costs a lot of money as well. So what's the problem? The vessels are large, not only to carry the equipment, but also the people and all the amenities that go with people. Now, if you actually look at a vessel, half of it is for the equipment, the other half of it is for the people. There are kitchens, there are beds, there are toilets, there's food, there's drinking water, there's gyms. They've got rec rooms. I mean, there's a rec room of a vessel down there. They've got pool tables. You've got to carry all this to sea with you. That makes the vessels quite large. Large vessels generate high levels of CO2, really high, if you actually look into vessels are particularly dirty, and they're extremely expensive to run. I mean, £30,000 a day is the cheapest ROV vessel. They can go up to £500,000 a day. Huge amounts of money. The other thing is that it costs companies an awful lot of money to send a person to sea on an ROV vessel. And a figure I heard a few years ago was about £1 million per person per year to do that. And that is when you start thinking helicopter transfers, insurance, offshore training, on top of the food and all the other bits and pieces and the wages these guys are paid. So the real question that the industry is asking itself at this moment in time is, can we reduce the size of these vessels? And can we reduce the number of people that are actually there? And we can. The solution that's now starting to emerge is uncrewed vessels. Vessels that don't have any people on board. These are remotely controlled. They are highly efficient and they are very, very small. And just by being small means that you can drive efficiency and lower your costs. And all they're designed to do is act as a launch platform for the robot. You don't need the bathrooms, the toilets, the kitchens, or anything else. And it's particularly attractive for our industry because everything happens under the water. So you don't actually need personnel on site. It's safer because you don't need people offshore. You can use smaller vessels. You can meet the legislation and reduce your CO2, and you can significantly lower your cost of operation. If you significantly lower your cost of operation, you can then open up accessibility to others who can enjoy the ocean or use it for exploration or energy or whatever. There's a lot of talk now about being able to try and convert hydrogen to actually use the hydrogen, convert that offshore, take it onshore, use it to generate electricity that's going to power all our electric cars that we're all going to be buying in the next 5 to 10 years. Also, as well as over-horizon control. So because the robots themselves are remote controlled, you don't need a person sitting on the boat above the robot. You could put them back on shore in the office. And that's actually what's happening right now. So the experts are getting moved from being on the boat to being in the office. And they can then control more than one robot at the same time. You can also have surveyors and other people who are interested in the data based onshore as well. And you do that with communicating via satellite. Now, up to now, that's been problematic because of the bandwidth restraints. But with Elon Musk's new space broadband technology, that is becoming more of a reality. We're starting potentially to get high bandwidth internet available across the world's oceans, as well as across the landmass. If you actually move more stuff onshore, you do have to start to make the robots more intelligent. They need to be able to look after themselves a bit better. Now, already there's a lot of advanced control features on these robots, but they need to be able to spot obstacles and spot risk and take action to avoid damaging infrastructure, damaging the environment, and damaging themselves. So AI is starting to play a large part in what these, how these robots control themselves. This is, before I go to the next bit, this is a picture of quite an advanced robot. It's done by a company called Houston Mechatronics. They are based in America. And these guys are ex-NASA guys. And they want to take it even a step further. They're wanting to not just use a robotic vessel, but to use no vessel at all. And this particular robot is a transformer. It folds up into a very streamlined torpedo-like shape and is launched from the shore and will transit to site by itself. That could be 10 miles offshore or whatnot. And then when it gets to the work site, it opens up and its arms come out and its tools come out, and then it conducts the jobs. And its operators are based onshore. It's pretty new stuff. It's pretty radical stuff. And the reason that's actually quite difficult to do is that you cannot get radio signals to transmit underwater. So what you could, you know that the US Navy and the British Army, they fly drones to Afghanistan. It's reasonably straightforward to do that because they can have very good communication links via the airwaves to that drone. When you move underwater, RF communications cannot penetrate the water. You have to start to rely on acoustics and possibly even lasers to communicate with the robots. That's really difficult to achieve. And that's actually just being looked at now to try and get the bandwidth to be able to see what the robot's saying to control the robot in real time. Otherwise, you need to rely on AI. Some of the more mundane things that uncrewed robots need, though, is they need to be very robust. They need to be super efficient, they need to be very reliable, and they need to have lots of redundant systems. And this is where some of the designs that we've been working on over the past 4 years start to come in. If the robot is going to be left on its own for 30 days or 60 days, you can't afford to have it breaking down. It needs to look after itself. So that's an example of one of the programs I'm looking after. This is one of our first new products called the Quantum AV. And just as an example, from an efficiency point of view, it's using up to nearly 40% more efficient than its predecessor. And this has been through very advanced power design and how we propel the vehicle through the water and the hydrodynamics of the vehicle and the size of the vehicle. The smaller something is, the lighter something is, the less power it uses. And that can equate to huge savings. 40% less energy, it's $200K, $200,000 of fuel saving if you're working on 24-hour ops for 220 days a year. It's a large amount. More efficiency, it means it's better suited to battery technology as well, because some of these new uncrewed surface vessels are going to be using batteries. And you really don't want something that's power hungry, or the batteries won't last very long. You need the machines to be really dependable, really strong. It kind of goes without saying, but actually it's tricky to do it because you don't want to be adding weight. You want to make sure that it's still light. But it needs to be strong and able to withstand being bashed around. The machines that we make are tools. They're just like the digger you see in the street. And you don't see shiny diggers. You see diggers that are covered in mud and are bashed around a bit, because that's just what happens in real life. And we need to make sure that our machines can withstand that. So environmental testing, temperature testing, vibration testing, that's and really good solid mechanical engineering has to go into the design of the machines. Super reliability on the machines. Now, clearly, we do have to make them waterproof, and over time that can cause a problem. These machines tend to operate near the bottom. The infrastructure is on the seafloor, and quite often the seafloor is covered in sand. Well, when you're working down there, sand can enter the water, and it's an abrasive, and it can get into the propellers and the seals within the propellers and things like that, and cause real problems. And we need to be able to counter that, and we need to make sure that we have ways in which the equipment will survive and keep going. And this is an example of one of our new propulsion units, and it has features in there that will allow it to last for a long time in pretty arduous conditions. This is the test tank at SMD, where we've been testing this new technology, where we cycled it for hundreds of thousands of times to check its reliability. And then finally, there's redundancy. So this is a close-up of one of our newest vehicles, and you can see that same thruster unit here and over here, and they're mounted in location. But also, as well as we need to make the components scalable for different models, so we can have different sizes of robot, and we do that through a modular architecture. And you can see the modular architecture at work here. These units across the back here are modules. They're power modules, 50 kilowatts each, and they can be stacked up to give more power or less power to the machine to suit the task that the client wants it to do. But it also gives redundancy. If one of these modules fails, we can isolate it and we can carry on working about on reduced power. And it's absolutely key that the vehicle has redundancy in modules that are self-contained throughout its construction. So that's an example of what SMD does and how we're using innovation here in the Northeast. Thanks very much.
Thanks for that, Mark. I'll just put you back onto. Could we all show our appreciation in the usual way with a bit of jazz hands for Mark? Thanks, Mark. That was fabulous. I mean, that was such a clear explanation of what it's all about. So I've learned a lot. I'm sure we all have. So thanks for that. We've got a couple of quick people who want to ask some questions. I mean, well, there's a first one that a few people asked, and I'm sure you could clear this up quite quickly, Mark. And there may not be a difference, but is there a difference between a drone and a robot, or are they just different words for the same thing?
They're different words for the same thing, really. Previously, robots, the term robot used to be that it could go off and do its thing without human intervention. So therefore, it has pre-programmed elements to it. So when they said robot, think of the Nissan car plant. It's programmed to weld something or pick something up multiple times. That's what they use the term robot for. Whereas something that's direct human control tended to not be a robot. But now the lines are getting blurred because your drones can now fly themselves pretty much. And you could just tell it to go left or right. So it is a robot because it has pre-programmed elements within it.
Good. Thanks, Mark. Castor, you had a couple of questions actually about NASA, and another question. Are you there? Are you able to?
Yeah, sorry, my computer's starting to show its age, so the webcam is a bit all over the place. Yeah, I was just wondering, is like the first question is does the technology that NASA develops for their rovers, is that eventually passed down into the sea robotics, or is water and a land robot completely different internally? And the second question is, are these robots typically purchased or leased by companies, and then SMD would just handle the maintenance or the running of the system since the cost is so high?
Okay. So it tends to be the other way around. The robots that NASA send to space, they tend to use technology that's not particularly cutting edge. And the reason for that is they want absolute dependability. And it's counter, you don't think like that, but they tend to use something that's been around for a few years, so they really know every single bug that's in that system. The robots that you tend to get subsea and on land or nuclear and other areas, we tend to maybe push the boundaries a little bit more, because if it doesn't work, we can go and get it. So it tends to be maybe newer technology. But once again, different technology. NASA has delays of minutes to be able to tell its robot to do something. We have delays of milliseconds. So we don't need some of the technology NASA needs in our robots, if you know.
Right. Okay.
The second thing is you get different layers. So we're the manufacturer, the OEM of the robots, and we sell them to the guys who lease the robots. So they tend to have our clients tend to have a fleet of robots. They will then lease them out to oil companies or Empower or whoever it is that tends to be needing the work done.
Okay, so similar to how a leasing company will buy aircrafts from Boeing and lease them to airlines.
It's a little bit like that, yeah.
Okay.
It's a bit like that. Yeah. I mean, at SM, we are starting to get into possibly looking at leasing directly to certain companies as well, but yeah.
Right, okay. Thank you.
Thanks, Kasra. Diana, you had a couple of questions or points you wanted to make.
I did. Thank you, Terry. Mark, really, really, really interesting. And you're very clear in terms of your presentation as well, which I think a number of people have appreciated and made a note of in the chat function. One of my questions was around the interface between satellite and satellites and satellite technology and underwater and underwater subsea robots. Mm-hmm. And I think you've communicated that really well. I'm wondering, do satellite I'm going to show my absolute ignorance here, for which I apologize. But do satellite comms actually get to the robot, or so how do the robot and the ship communicate with each other?
Yeah, that's a really good question, Dina. So not directly. So what would normally happen is you would, from your land-based station, you would jump on the back of a terrestrial telecom system, mm-hmm. and then it would go to satellite providers' servers, for a better word, go via the satellite link, which we provided by a company. That satellite link would then be picked up by a satellite base station on the vessel. Yeah. And then the vessel would then turn that into a fiber optic.
Right, okay.
The robot. So currently the robots that we do are connected with a cable. And the reason they're connected with a cable is so that they can have continuous power and continuous communications for days on end. It won't run out of power. The real problem comes if you don't have the vessel, as to how do you speak to the robot with the satellite,
with the robot, yeah.
Mm-hmm. So some companies are coming up with floating buoys that would sit on the surface and connect with satellite dishes or with radio frequencies through the air, and then have an acoustic transducer, a sonar system underneath that can communicate through the water via sound. But the problem is always the bandwidth and the speed at which they communicate. You know, fiber optics is instantaneous, whereas you're really restricted when you move to acoustics. There's only a certain speed sound can move, and there's only a certain amount of data you can put into a sound packet of information.
And are there environmental considerations with regards to acoustic? I was thinking about impact on sea life.
No, not really.
Marine animals.
Yeah, I think you've got to be a bit careful. People have talked about this for quite some time, but it's not. There's been no evidence of it changing migrations. It's not powerful enough, really. It's quite directional. It's not very far. Mm-hmm. You do get environmental effects from from waves as well. Because if you have waves and a lot of foaming at the surface, your transducer needs to be through that and below that, because sound won't go through foaming or aeration in the water. It's a big problem getting that communication element sorted, and that is driving us to things like NASA technology. So to use an example for this, so NASA can't communicate directly with their rovers. They can, but there's a huge delay. So they cannot say, they can't do what I call real-time stuff. So real-time stuff is you want to pick something up and you can see it on your camera. So you move your arm in relation to what you see. That's how a human will interact, and that's how we do it with the robots currently. With NASA, they can't do that, because if they press go, the arm will take 10 minutes to move and you can't control it. So what they do is they use a digital twin, and the robot will scan the area it's trying to do something with, and then the operator will do that in the virtual world and conduct the operation in the virtual world, and then press the send button for the robot to then do that at its own time. So then disassociates the time for when you do something for when the robot does something. And that is a NASA technology.
Yeah, so this is really relevant to Elaine, who's also on the session this morning. Elaine's the Centre Manager for the Satellite Applications Catapult Centre of Excellence, and is looking at digital twinning, aren't you, Elaine, at the moment?
Yeah, sorry, Terry, am I okay to jump in?
Yeah, I was going to do that very thing. So yeah, thanks, Diana. Yes, Elaine, please do.
Okay, so I was just about time, because I do have to go for an 11 o'clock meeting. I was typing in a chat, but I'll just very quickly say, so in the chat that I was about to send, I said, thank you very much for the presentation, Mark, really interesting. Just as you were explaining the challenges there, those are exactly the kind of challenges we're trying to solve with some of the businesses that we have in the region in the Northeast. In the chat also, I've flagged up a European Space Agency funding call that we're looking to respond to.
All right.
And that's specifically looking at smart and uncrewed shipping. What we'd really, really love to have is for such a project to come to the Northeast.
Right.
Actually trial it in the Northeast.
Yeah.
Those who are in the know, these ESA funding is highly competitive.
Yeah.
I think they're usually, one successful project in a nation, in the case of UK. So we're really keen to pull together a really strong project with a number of potential partners, some of whom are in the room. Oh, sorry, green. Yeah, it'd be good to have a chat, outside, well, after this event, because I have to.
Please get in touch, Elaine. I'd be really interested in a chat about that.
Yeah, it's quite a good funding. Anyone else who's also interested, please get in touch, because these demonstration projects are potentially up to about 2 million, so it's well worth considering. Yeah. So I have to go.
Before you go in, if you share some information with me, I'll circulate it around everyone afterwards.
Okay, it's in the chat anyway, the bit that.
Oh, right, brilliant.
All right, thanks very much. Bye.
Thanks,
Bye, Elaine.
Bye.
Thanks, Diana. Diana, you had another question?
I had another two questions. Yeah, sorry, I don't want to hog the floor, but one was about the interrelationship between artificial intelligence. Sorry, not like immersive technology. Sorry. So I'm just kind of wondering. So I know that there's a massive, great big use of immersive tech in terms of engineering, many different types of engineering, maintenance, and so on. I'm wondering, is immersive tech increasingly being used in the management and operations of the robots? And then my other question was about batteries and battery material manufacturing. I know that there is a big discussion nationally about battery materials and batteries for marine, and I'm just kind of wondering whether that is also heading into the battery material recycling discussions, because I know that's something that CPI are really interested in looking at the moment, and there might be some benefits of CPI talking to SMD or to other marine battery people who they may or may not be connected with.
It would actually. Okay, really quickly to answer the first question. Yes, the immersive technology, so VR is going to start to play a big role in the robots. The reason being is that if you can get your head with your VR headset on and actually get rid of the robot itself, and the virtual arms can be your arms potentially,
Right.
and they mimic exactly what the robot arms are, then you are essentially transporting yourself to the work site
Yeah.
in real time. And VR technology has been jumping quite a bit, especially in the last couple of years, actually, that would allow us to do it. The biggest problem it's got is that it needs a lot of data. And that's getting back to our over-horizon bandwidth limits. Or you need to do a lot more processing at site and come up with a way of representing that over horizon. But yes, it's going to be a big thing. The second question, batteries offshore are a really, really hot topic at the moment. And we've been looking at what the current share have been doing. And the current share have been doing the standard LiPo type cell idea that we're used to. You get an electric bike, you get an electric cars, da 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 da. The problem we've got with using those is that when you go subsea, you do need stuff that's pressure tolerant. Otherwise, you've got to build a box that can withstand the pressure. If you build a box that withstand the pressure, the boxes can be huge, really thick, really heavy, bit of a pain. And what we are really interested in is new battery technology that starts to integrate the cell technology into the structural material. And certain people, so this is like solid state battery technology, really interested in. And then the other one we're really interested in is there's been talk of new environmentally friendly batteries, which use salt, for example, sodium-based batteries. That's of real interest to us as well.
Okay.
So we are actively looking around. It's one of our next programs to try and see if we can work with some people to actually bring on battery technology for the marine environment. Certainly.
Can I connect you with Tom Taylor and Charanjit and
Yes, please.
Mike Clausen, CPI?
Thanks, Dan.
Thanks, Dana. Actually, you touched on immersive tech. Dan from Infinity 27, I think you had a question or a point to make.
Yeah, thanks. Yeah, it was basically in regards to immersive. So you mentioned accessibility was one of the problems, and it was kind of, do you mean there's kind of a training barrier or real-time barrier to kind of operating the robots? Is this very expensive to train the specialists, or current training solutions already deploying this and kind of it's not really a problem there?
No, we can definitely see a role in the training side of things. Being able to transport people into the control rooms, or especially when maintaining the robots, being able to work on a virtual robot. And we've been experimenting with that actually back at SMD, where we brought the models in and we can expand the models, and we've been, it's something that we're quite interested in doing. I think that'd be quite useful. The limitation on the controllability of the robots is down to the timing element of it. There's two ways you can control a robot. You could, if you're doing survey work where you're just gathering data, you can actually tell it to go off and do its thing because you know where you want it to go, you know where you want it to look. The problem comes in where it's identified something through its AI and it says, hey, come and have a look, right? And it brings up the guys back at the control center and go, we might have a problem here. There might be a leak, or there might be, I don't know, an anchor on a cable or whatever. That's when you want to be able to take real control of the robot, where you can say to it, get in there and look. Now that's what I call command to control. And once again, that doesn't quite require real time, because you could just say to it, go closer, go left, go right. It's when you want to do the remedial work that you need the real time control. That's where it gets a bit tricky. And there is talk about doing that with AI, but companies like Npower or Exxon or anybody else get really nervous about getting a robot to touch their asset with a big drill in its hand that you think, don't worry, it'll be fine. It's going to give you a call in half an hour when it's done the job. And because they're just like, whoa, we really want to see what's going on in real time, or we want a trained technician to be on the controls who knows how this works, because there's always a problem. The problem with subsea is it's not like a lab. There's going to be fishing net over it. There's going to be marine growth on top of this thing. You've got to, it's like working on an old car. You've got to get in with a wire brush and clean it off before you can actually start to do the maintenance. I hope I answered your question.
Great.
Yeah, thank you.
Thanks, Dan. We've got time for two more quick questions. So there's Phil Wainwright had a question about maintenance.
Yeah, sorry for the delay. I was just unmuting. I was interested in the uncrewed vessels. And the question is, when they are deployed to site, how does routine maintenance of the ROVs get carried out?
It doesn't. So that's the challenge that we're doing now. So the ROVs, we've got tenders in just now where they're saying that the vehicles must be able to go to sea for 30 days without any intervention whatsoever.
Oh, right. That'd be a very interesting project. But yeah. I was just trying to work out, because I'm ex-Navy, and of course, maintenance when you're at sea is always an issue. And I was just trying to work out how on earth an uncrewed vessel could even, do the more basic things, let alone anything else. But yeah, it'd be interesting to have a chat with you about that later.
Sure, Phil. Yeah. Well, people who know about the robot industry up to now have been involved in it. They all say the same thing as you're saying. They're like, "Ooh, right, how are you going to do that?" Because
it's obviously come on. When I was in the Navy, we did a bit of ROV stuff back in the early mid-80s, and at that point, the problem was how to untangle a tether, a snag tether and things of that nature, reversing steps. So it's obviously come on a little while, but I think, some of our technology, and certainly low bandwidth communication, might be something that we could have a chat about as well.
Yeah, sure.
What I'll do for Mark and Andrew, our next speaker, I'll say your contact details to everyone as well afterwards. Yeah. So if anyone wants to get in touch with you, they'll be able to do that. Yeah. And then finally, Luke had a question about pirates.
Oh yeah, that's a good one.
Yeah, hi. I'm really interested by the idea that we're kind of trying to put fewer people and vessels out into the ocean, but obviously that comes with the leaving them out there on their own and potential for theft. So I was wondering how you solve that particular problem.
Yeah. Do you know what? I don't know is the answer, but I do know that it is something that's high on the agenda for these uncrewed vessels, as is also rules of the sea. If there's not a captain on board, what happens if there's a collision, or what happens if there's something happens? And I know that we're not a vessel company, but I know that a lot of the people who are developing these vessels are trying to solve these, you wouldn't think are normal problems, but are real big problems, and piracy is one of them. I mean, what's stopping somebody just lashing a rope to this vessel and towing it back to Somalia or whatever, they do with it nowadays? I think it could be a real problem. So, yes, I don't know.
Okay, thanks for that, Luke. Right, thanks again, Mark, for that, for your presentation. Welcome, Andrew. I'm just scanning my screen for Andrew so I can highlight him. And there he is. Right. So, Andrew from Resolve Robotics, who also sends robots into strange places. So, Andrew, over to you.
Why, hello, Andrew.
Can everyone see those slides okay?
We can, yes.
Yeah.
Excellent. Get you all back on the screen 1 second. Right, there you are. Hi, so I'm Andrew Lidar-Smith. I'm the technical director and founder of Resolve Robotics. So we're a small and relatively young company, and we're a technology development company. So a little bit different to what Mark does, which is kind of building robots and then having them sent off to actually be deployed subsea. We're really focused on not what we can build today, but what can we build in 5 or 10 years time, and trying to change that from being 5 or 10 years time to being 2 or 3 years time, hopefully. So we were set up in August 2019. We took on our first employee in March last year. And since then, we've grown to a total of 10 full-time employees. And because of various other things that have been going on over the last 2 years, we're a remote first company. So what that practically means is that we've got people from Aberdeen down to Birmingham. And that's worked quite well for us. It's been really helpful in terms of disruption, not having an office. So our primary business is really catering to large industrial clients in the nuclear industry. And that's for two reasons. One is that's my background, working on robotics and radiation instrumentation for the nuclear decommissioning industry. And the other reason is that I live about 10 miles down the road from Sellafield. So everything accidentally becomes a nuclear project, it seems. What I'm here to talk to you about today is really the technology that we've developed for our nuclear industry clients and how that translates and has applications to subsea robotics, and more broadly around some of the work that we're starting to do now and generally our vision going forward for subsea robotics. So here, a few things about what we do. So we have an in-house team. We can deliver everything from bespoke electronics and mechanical design through to robotics algorithms and various types of software that we need to actually deliver full solutions. So we go from early stage requirements gathering with our customers and conceptual design through to final testing, deployment, and ongoing support. So we aim to be this one-stop shop for our customers. So innovation, it's really kind of an overused word. We use systems thinking to generate what we think are optimal solutions to underlying challenges. And we've got a process for doing that. So it's not just a case of sitting down and going, well, what exciting, cool robot am I going to build today? It's actually looking at what the customer's needs and problems are, what all the stakeholders are involved in that final solution. So it's not just the person sitting there with the big fat checkbook who's actually going to write you the check to build the robot. Yes, they're pretty important, but it's actually everyone else that's involved in that life cycle. So to take Mark's example, it's not just that oil and gas company that's actually going to pay for the work to be done, but it's how does the guy that's got to do the maintenance on the robot, how does the design that you're doing impact on him? It's all well and good building a robot solves a problem, great. But if it's almost impossible to maintain, then that's equally not ideal and causes a whole lot raft of kind of wider problems. So that's part of our design process. And lastly, we kind of celebrate taking ideas and inspirations from a wide range of other sectors. And I've kind of got some examples of that I can talk about after the presentation. So we also connect dots. So we work with industrial users, like end users, so Sellafield, National Nuclear Laboratory, Dounreay. And we also work with academics. So one of our strengths as a company is taking what's fairly cutting edge academic research and then applying that to solve actual industrial challenges. And lastly, we're really open to working collaboratively. So this includes other SMEs, large corporations, as well as startups and academia. So on the subject of subsea robotics today, kind of four things I'm going to cover. One, I'm going to present our ROV. This is the first time I've really kind of publicly talked about our ROV and what it is. So that's really exciting. And next, I'm going to kind of talk about the services we can provide to other companies. So we offer contracting consultancy services. Specifically, our strength lies in hardware software integration. So I'm going to have a quick talk about that. And then I'm going to talk about a couple of other things that we're starting to work on, really planting the flag and kind of waving and saying this is something we're doing, and making people aware of that. So big thank you to Mark, who's given an excellent introduction into what ROVs are broadly. This is our ROV. So it's unlike many other ROVs, this has got a full 6-degree freedom movement. So it can roll, pitch, yaw on spot, as well as move in any direction. And that's quite key from a robotics and autonomy point of view. Even more critically, this RRV features a stereo camera pair. It features a high performance processor and an embedded GPU. So to give you an idea, this is about equivalent to a top of the range gaming PC on board the RRV itself. And what this enables us to do is a wide range of kind of autonomous functionality to be implemented onto the RRV itself. So we can do SLAM, which stands for simultaneous localization and mapping. So what this is, it's robotics algorithm, or our whole family of robotics algorithms. And what it lets you do is it lets you build up a map of the environment without having any map to start with. So it goes out into the complete unknown and it starts to build up a map as it explores around. And then that's useful because it lets you navigate autonomously. It's useful because you can then export that 3D model of the environment later, and you can use that for inspection. And so you can see, to take a nuclear industry example, if we're doing this in a pond, we can see, we can identify features like pieces of debris, pieces of fuel rod, and we can measure, for example, the amount of sludge in a pond, and we can see between month 1 and month 2 how much of that sludge has been successfully removed, for example. It also lets us do autonomous path planning. And the other thing that this high performance processor lets us do is we can run computer vision algorithms on board. So that lets us do object detection tracking, so we can make sure that we don't bump into things in the environment don't bump into us. And it lets us run machine learning for identification and classification features. So for example, if you're doing the inspection of a vessel, you can identify visual faults such as cracks. We also feature up to 4 terabytes of onboard storage, so we can record pretty much everything for potentially weeks to months at a time. And really critically, from a research point of view, it comes pre-configured with ROS, which is the robot operating system, and it comes configured with that out of the box. So this is quite unique for an ROV. This means that if you want to use this for research purposes to explore any of this autonomous capacity as a researcher, you can take it out of the box and you can start doing the interesting research immediately. As opposed to the current status quo, which is that you pretty much have to buy an ROV and then you have to start working out how you're going to get all this robotics functionality, and that could potentially be a 6 to 12 month process before you've really done any new and original research. And lastly, this can be continuously powered down the tether without any onboard batteries, and this is fantastic. This removes potentially explosive batteries from an already very safety conscious environment. And from an R&D point of view, this also means that you can run your ROV in a test tank indefinitely, rather than having a flight time of a couple of hours. It also fits through a 3-inch hole. So this is orders of magnitude smaller than any other ROV that is commercially available. And this is really unique for us. And what this lets us do is internal inspections of tanks, vessels, and pipelines. So we can put this into these environments. We can use the stereo cameras and the onboard processing to build up a high resolution 3D model. And that's really critical for our nuclear clients because that lets us go into these highly active environments. These are vessels and tanks that you can't necessarily just walk up to the outside of. And what this lets them do is actually pilot this ROV into the vessels through the water inlet pipe and do a full inspection. And that lets them quantify those assets and make sure that they are in a suitable condition to continue running for the next 20 years. And that, for them, solves hundreds of millions of pounds worth of potential liability if anything were to go wrong. It also enables a couple of interesting things from a subsea point of view. So we can deploy this from larger vessels and larger ROVs for close inspection work. And one of the things that we're looking to explore further with this is to use this as a third-person camera for a larger work class ROV. So what that'll let us do is, rather than being limited to a camera that's physically attached to the front of the ROV and you're only ever going to get a first person point of view, if you're piloting the ROV from a first person point of view and you get your tether stuck or some other issue happens in the environment around you, you've only got that one camera, and it's very difficult from personal experience to work out from that first person camera what's actually gone wrong. So in this scenario, what we'd see is our ROV would detach and give you that third person view behind you, or and just give your pilot a much greater sense of situational awareness. So this generally fits into our mantra at the company, which is smaller and smarter. And that applies across all of our projects. And that can be a really big challenge at times, especially with ROVs. You still need them to float, or, well, not sink like a brick. What you're aiming for is neutral buoyancy, and that gets vastly harder as you get smaller. If you've got a large ROV, you can add weights or you can add floats to kind of trim your buoyancy. We don't have a lot of spare volume to do that. And so we have to be very careful to account for every gram of material that we're adding to this, to make sure that we do achieve that neutral trim. And that, as we go from, for example, like a 6-inch ROV down to a 3-inch ROV, you half the diameter, and that means you eighth the volume, and therefore you eighth your mass budget. And the mass of your outside enclosure is only halved, or quartered rather. So it gets more and more problematic as you get smaller. So next slide, kind of talk about where we are with this at the moment, really. So we've got demonstrations booked in with the Ministry of Defence and the Nuclear Decommissioning Authority for June this year. So we're going to have, there's a couple of interesting things we're doing with those demos, especially the Ministry of Defence one. So we're working with a company called Cyberselves. They make teleexistence software for robotics. So how this demonstration is going to work is our ROV is going to be up in our small tank in Cumbria, and they're going to take a VR headset down to London, so 200-300 miles away, and they're going to pilot the ROV remotely from London using the headset. So as the pilot turns with his head in the headset, the ROV is going to turn. So it's as if the pilot themselves becomes the ROV. And future work we're going to explore with this is actually to have 2 secondary ROVs with small manipulators on, which will effectively become the hands of the pilot as well. And that's where we're hoping to take that project. So one of the things that we're quite keen to do is, like I mentioned, is accelerating technology development. So it's not what can be built today, it's what could be built in 5 or 10 years time, and then let's try and build it today. So this has been a 6-month total development timeline from when we started conceptually thinking about this project through to our demonstrations in June. Is going to be 6 months, and that's kind of a key thing of what we try and do. So yeah, this is the world's smallest commercially available ROV. It's fully bespoke electronics and mechanical design. But critically, we've also got an open source software stack in here and a hardware interface. And what that means is that this is useful for researchers. So if you're interested in doing any kind of autonomy or computer vision applications for underwater robotics, then this is a really good platform for you to do that. You can do it in smaller tanks, and you can do it in real life rather than simulation. And it's fully set up, ready for you to do that. So we're opening pre-orders for this at the start of May, and we'll have those finished products in the hands of customers by the end of this year. So our future work in this area, our micro ROV is really designed to do visual SLAM, and to use those stereo cameras to build up a 3D model of the environment. but we can do designs smaller and larger than this. So we're discussing doing a version with an embedded EMAT sensor. So this is an electromagnetic acoustic transducer, and basically it's some magnets and some wires that vibrate very quickly and generate sound, and those sound waves can be used to measure the thickness of, for example, the wall of a vessel. And so that's probably going to be in a slightly larger version, which will be around about 100 to 150 millimeter outer diameter. And equally, we have designs, we can push the size of our micro RV down even smaller and to fit through 1 or 2 inch holes as well. So next, I want to talk to you about something else we do, which is hardware and software integration. So as well as doing bespoke development for industrial end users, we also provide consultancy and contracting services for our clients. So I'm going to talk to you about a project we've done over the last year. And this came to an end in March. So this project is to demonstrate a prototype for an autonomous ROV for remote inspection and intervention within nuclear ponds. So there's a consortium on an Innovate UK funded project, and we were brought in to support our clients on the hardware software integration. So our clients are an engineering company and not necessarily particularly focused on autonomous software. And so we enabled them to integrate the different software and sensor packages onto this ROV and allow it to do all the functions that it does. So I'll talk briefly about those. So one is a collision avoidance system. What that does is it makes sure that if there's an obstacle around the ROV, that the ROV won't move into it. So any commands that would be sent to the thrusters of the ROV to move it, instead pass through this piece of software. And this piece of software is also provided with information on the environment. And it looks at the two, compares them, and if that movement command would result in the ROV bumping into something, it sort of vetoes it and doesn't send that command down to the actual thrusters. There's also a SLAM system provided by another company, which has been integrated on here. And the interesting part that we developed for our clients on this project is these cameras that you can see around the bottom here. So we developed a computer vision algorithm to run on board the ROV. And what this does is it simultaneously detects and tracks obstacles around the ROV. So for example, if there's another ROV in the environment, what it'll do is it'll give you a distance to the ROV and a direction. And so that's the information that gets fed into that collision avoidance system. And what's kind of interesting here is that we're actually running that in real time across 8 different cameras at the same time on board the ROV. So we had to parallelize the algorithm to run on board a GPU rather than a CPU. Probably getting a little technical here. The long and short of this is that kind of we're available to support your research projects. Slightly shameless self-promotion here. Yeah, reach out to me, have a chat. We're always happy to kind of meet new clients and talk to new people and see how we can help. So now I'm going to talk about a couple of things that we've not done yet, but we've started looking at. And this is really just us kind of putting a flag in the sand saying this is something we can do and this is something that we want to do going forwards. So we can do near photorealistic simulation for computer vision. And why is, I guess the question is, why is this important? And the reason this is important, I think Mark touched on it really well in his presentation, is that sending things offshore is really, really expensive. And even if you do it in the cheapest possible way, it's still expensive. Even if you go and test it in a pond, it's still really expensive. What would be fantastic from a development of autonomy point of view is if you can simulate as much as practically possible. Where that there's definitely robotic simulation equipment and software out there, but they typically look terrible. And your problem there is that what you can simulate movement and things. What you can't typically simulate is your computer vision algorithms. And so what we're developing is we're using video game technology to allow photorealistic simulation. So we can take the camera perspective from the video game, and we can use that as a camera for the robot. So we can run the simulation, and the key bit here is being able to simulate the environment in such a way that the optical effects of, for example, water, ambient light at the surface and things actually pass through in a realistic way, such that you get the same results from your simulation as you would from real world data. And needless to say, this is quite hard for a whole bunch of reasons. And so a couple of other things here, just signposting things that we are intending to work on. I've mentioned previously our ultra small ROVs. We intend to continue working on these, develop a whole range of different products. We've got an Innovate UK project at the moment, which is looking at modular manufacturing, and that's really focusing on how do we manufacture a wide range of different products all at the same time. And so we're planning to use tie that in with our small ROVs as well as the rest of our products. Next, we've got an integrated low-cost SLAM and autopilot system. So what we want to do is we want to develop a sensor package which can detect the environment and also allow for some autonomous functionality. And what we want to do is basically take what would be the tether from the ROV, plug it into our SLAM package, and that SLAM package can then pilot the ROV in place of a manual operator. And what we have for the nuclear industry is a wireless solution, which won't translate offshore particularly well, but for the nuclear industry, what this lets them do is remove the tether into the pond completely. And the last 2 points here. So we're also working on a depth camera for collision avoidance, and the intended application of this is that it's a single camera. So it'd be about the size of your fist. And what you can do is you can plug that onto the outside of your autonomous vessel or ROV. And what that'll do is simply provide a straightforward set of information as to what, if there are any obstacles in the camera frame, and if they are, what angle and what distance they're at. And lastly, we're interested in autonomous launch and recovery for our small ROVs, including the ability to recharge and transfer data to them without needing to mate an electrical connection underwater, which is a fairly challenging thing to do. So I hope that's given everyone kind of an interesting insight into kind of what we're doing right now, and where we see ourselves contributing to subsea robotics going forwards. I'm more than happy to kind of connect with anyone. I'm on LinkedIn, and kind of my email's on the slide there. And I'm also happy to take any questions.
Thanks for that, Andrew. If we could just once again show our appreciation in the usual way. There aren't many questions in the chat, but what that usually means is that you've kind of blown everyone's minds just a tiny bit. I think the comments are, what? How on earth have you done that? But if anyone has managed to kind of gather their thoughts and is in a fit state to ask a sensible question or even a non-sensible question, then give me a wave and I can hand over to you. Trevor, was that a wave from you, or oh, Yvonne?
Yeah, I was going to ask you about the systems thinking. It's not very often you hear people mention that. And I was just curious about how you guys came to learn about systems thinking and where you draw your inspiration from.
Yeah, that's a really good question. There's kind of two answers to that. I think the first one is like I was taught it academically. The kind of part of my master's program, we were academically taught to do systems thinking, which didn't really resonate with me until I went into industry and saw people not do it. At which point that really drove the message home of okay. And so I spent a few years kind of watching people not do it, and then yeah, so that's something that I'm quite keen on making sure we do.
Yeah, ditto.
We've definitely got kind of practical examples. It's definitely it's a key part of our process, and it's something that's working very well for us.
Thanks, Yvonne. Dan, you had a question about engines and things, which I don't understand, but there you go.
Yes, thank you. Thanks, Andrew. I was blown away, especially when you showed the can and said it was going to fit through this 3-inch gap and that you had 6 months. I was like, wow, that's super ambitious. But I had a question about kind of the photoreal sim that you said. Are you using Unreal Engine or Unity for that? And if so, are you doing that in-house or are you seeking partners to help? And that's a shameless self-plug as well.
Yeah, we're using Unity, and we are so we started doing it in-house. We're probably intending to do quite a bit of it in-house. Like I'm super happy to kind of like have a conversation further and stuff. So like, yeah, absolutely reach out to me. I won't promise anything, but I'm certainly happy to have a chat.
Thank you very much. Cool.
Thanks, Andrew. If no one has anything else, we'll leave it there. But again, Andrew, also Mark, huge thank you for joining us today and showing us some amazing things that I'm sure most of us never seen before, but we're now all much more aware, much more educated, and just a little bit inspired, I think, by some of the stuff you've been doing. So a huge thank you for that. We've now got a couple of people who want to just take 2 minutes to tell us a bit about who they are and what they do. So we have Jan from Marks and Clark. Jan, can you give me a wave so I can highlight you? No.
Hi, Terry.
Sorry.
I am Jan from Marks and Clark. I can't remember actually asking to talk, but I'm more than happy to do so if you just give me 10 seconds so I can retrieve the...
Well, I'll tell you what, shall I come back to you? Because we've got a few with us, so it's just 2 minutes to say,
Perfect.
This is who we are, this is what we do, and this is what we offer.
Just
so
give me a couple of minutes then. Perfect.
That's fine.
Thank you.
So we have Lavinia from Triad. Is Lavinia still with us?
Yep, I'm here.
Oh, hi. Just
hi.
There we are.
Hello. Yeah. So am I okay to share my screen just for 2 minutes, or?
If it is 2 minutes, that's fine. Yes.
Yeah, 2 minutes, absolutely. There. Can you see that?
Can, yes. Right.
So just really 2 minutes very quickly. So I work for a research and innovation consultancy. We're into an international consultancy. So we work a lot with the UK, but a lot with France as well. And we offer like bespoke support for your innovation projects. That means we try and make sure you get funding for your project. We do grant bids, we do awards, we also help you with private investments. So if you need any like documents, we build it for you, but we also support you on a longer term basis, 6 to 12 months if you need to structure your whole like research and development roadmap and pathway and all your different like maybe side projects that also need funding. So we really try and make sure that you can get to your innovation as quickly as possible. We also have quite a lot of partners with who you can connect with. So be it on the technical side or on if you need commercial partners, things like that. We've got clients that are really early stage startups, but we've also got clients that are Fortune 500 companies, anything in between. So there's no like scale. And like I say, quite a lot of partners that you can connect with. So if you want any help on that, if you want any more information on what we do, obviously, get in touch. We have our main office is in Leeds, but we are opening one in Newcastle at the minute. We haven't got an official address yet, but I'm here in Newcastle. So yeah, just get in touch if you need anything.
That's great. Thanks, Amelia. I'll also share the details of everyone that does the pitch as well, so
Thank you.
can connect afterwards. So if you could...
Yeah, sorry, I'm trying to... I got it off. There we go. Sorry.
There we go. Great, thanks for that. And we have Paul from EVAC.
Hello, everybody. Hi there. Yeah, just take a couple of minutes of your time. From EVAC Engineering, we've been in business in the Northeast for about 40 years. We have an engineering facility of 20,000 square feet with a machine shop, fabrications, powder coating, power pressing. So anything metal, we can usually manage to get your end product out of it. Spend a lot of time working with businesses in the area on simple day-to-day solutions to their problems. We work with companies that need to keep the process lines efficient and do breakdown recovery and things for them. And we also work with new companies that have got new ideas where we help them with getting from concept to prototype to samples to production. Some examples, we're working in the recycling industry with a patented process which is being rolled out over the next 5 years. We're preferred fabrication supplier on that for the next 5 years. We're working with a UK facilities company where they've closed down their own engineering facilities. They've lost a lot of the information, so we're going to be doing some reverse engineering to get them the parts they need to keep their own operations functional. We're working in fire safety. Legislation changes are coming along, and we're rolling that out with a trademarked product, which we're probably launching. We've already sold some, but we're probably launching the trademark in the next month or so. So any engineering things we can look at. If we can't do it, we can usually help people find somebody that can. I think that's my 2 minutes.
Thanks for that, Paul. And now we have Yvonne from NEL.
Hello, thanks very much. That's great. I'm Yvonne Gale, NEL Fund Managers, and we finance growing local businesses. But I'm here today to talk about two specific offers that we've got running. Our target markets are businesses who are looking to grow and might maybe need some money to do that, but also, you know, those in the room who are advisors to businesses who need to know what's going on. Really, I'm speaking to sort of both groups today. For the businesses themselves, I'm just highlighting we've got a programme coming, free support on Let's Talk About Money. And it's great if money's not your favourite subject. It's specifically designed around that. So if you find talking about business finance a bit painful and you maybe think you could improve, that's the one for you. We're also raising awareness on the recovery loan scheme, which is the new government-backed loan product, which replaces Sybil's and the bounce back. So they've gone, ship has sailed. Recovery loan scheme is the new game in town. And our offer is if you, or perhaps on behalf of your clients, would like a briefing on that, please do get in touch with me. We're very happy to arrange that briefing. We're actively trying to get out into the market what it is, what it isn't, what it can be used for, how it might work, because I think people perhaps have some assumptions based on the last ones and it's not the same. So please do reach out to me if you want to know about the recovery loan scheme, and details of Let's Talk About Money are on our website. Thanks very much.
Brilliant, thanks Yvonne. And now, is Lloyd still with us? Yes. Lloyd, over to you.
Yeah, okay. Well, I'm a student at Newcastle University. Well, as before, I've just taken a sabbatical for a year. Before that, we are into sales and service partner for HP, large format printers. And during my sabbatical here, I'm doing my MBA at Newcastle University. We're working on a project for predictive future health analysis. We're controlling chronic diseases, which we can expect in the next 5-10 years for an individual person. So that's my project, which I'm working on right now. So it's on an ideal stage. So I just need some help to get connected with the right person from that. Yeah, that's about me.
Okay, thanks, Lloyd. I mean, if you want to send me some information about what you're looking for, a bit more specifically, perhaps we could help afterwards. So, but if anyone in the room could help Lloyd or is interested, then please do get in touch. Thanks for that. Jan, can we go back to you again, please?
Yes, please. Thank you, Terry. Right? Thanks for your patience.
That's quite all right.
Yeah, so very quickly. So my name is Jan Robin. I work for Marks & Clark, and we specialize in all aspects of intellectual property, including in particular patents, trademarks, and things. So the emphasis really is on helping our clients protect their innovation. So Marks & Clark has 9 offices across the UK, and including 2 offices in the north of England, including Leeds and Manchester, and 2 slightly further north in Glasgow and Edinburgh. So personally, I'm located in Glasgow. And our team covers all areas of technology. So personally, I specialize in health and medical devices, chemistry, which is my background, and energy, including oil and gas, and I do a lot of subsea excavation and exploration as well. So today was of particular interest to me. And my connection, to the Northeast is also that I did work for a year in the Teesside area when I worked for ACI at the time. So I have an interest in that region from a personal point of view. And so in summary, Marks & Clark is there to help people secure, but also defend and exploit intellectual property rights, starting in the northeast of England and beyond, as innovation progresses and develops. So from the initial stages to all the way to enforcement and exploitation. Well, that's
great. Thanks for that, Jan. And then we have, I mean, it's not so much a pitch, but Dinah Jackson from the LEP, who was kind of not so much the instigator of this event, but it was from discussions or conversation with Dinah, we decided that this would be a good theme to for this. So, Dinah, do you want to say a few words about the
yeah, absolutely, yeah. Thank you, Terry. Hi, everyone. Nice to see a few of you that I know, and great to meet people that I don't know. I am the Innovation Programme Manager at the Local Enterprise Partnership. We have an innovation programme that is part of the Strategic Economic Plan. A couple of very specific things to call out in that regard is one, that we are doing some work at the moment to support partners, work with partners who are investigating the potential to grow the Northeast market share in some emergent markets. Robotics for offshore is one such, battery materials manufacture is one, immersive technology, once we've got the aging, fintech, cybersecurity, and space technology, and a number of others. So we've got 11 what we're terming innovation delivery partnerships, which are in various different stages of formation. they're basically cross-sector partnerships of organisations that are coming together, so universities and private sector business, financiers, government agencies and so on, to really explore how market share can be increased through innovation, through commercialisation, through collaboration, through knowledge sharing, etc. A number of people on the call are involved in these IDPs, the Innovation Delivery Partnerships. One aspect that we're exploring is the role of design to all of those partnerships, and kind of mechanisms that are available to us as an organisation to bring partners together who might not normally have the serendipity to meet each other. And I think this session this morning has really shown just how valuable that kind of bringing together of people from different walks of life can be, because actually there is a lot of commonality as sectors are getting much more blurred and there's convergence between the technology application across different industries. This kind of operating and networking environment is going to become increasingly important. That's really been clear to me this morning. I just thought it would be useful to mention one other thing. In relation to the innovation programme, one of our areas of concern is what we call the innovation ecosystem. So how well does the ecosystem in the Northeast support innovation and innovators? 5 main components to that innovation ecosystem. One is talent, one is hard infrastructure, that includes digital, one is knowledge, access to it, deployment of it, one is money, how well does money circulate, and how well investors connected with potential investees and innovators, and one is the broader business environment, which encompasses the business enterprise innovation support that is available to you as businesses to assist you to grow. We're developing an innovation toolkit which will talk about the broader business environment and finance that's available within the broader business environment, that will be hosted on the Northeast Growth Hub. But we really search for content, and some quite unusual content. So it's telling the stories about you innovators out there, or the financiers and funders who are giving awarding funding to innovation, and particularly looking for unusual stories. So we do Ask the Expert pieces or 2 minutes with a business, which are more kind of conversation, either written or video pieces. I'd love to hear from anybody who would want us to share their story and share their content and inspire others and help to make connections. And yeah, the other shout was just really be aware of the Northeast Growth Hub. It'd be handy, Terry, to send the link round to the Northeast Growth Hub. That's a website that is a resource of information on the business support and finance schemes that are available locally, regionally, nationally to assist businesses to grow and to assist startups. So it's a good wealth of information on there. We do also have a team of connectors who are available via the Growth Hub to assist you to find the services or support that you might well be looking for.
Great, thanks, Diana. I think I would imagine everyone in the room has an interesting story to tell, and they'd be happy to share it. So I'll remind everyone of that in the email that will go around early next week. So thank you to everyone. I've just got a couple of quick slides I want to share. So I'm going to do this. How do I do it again? Here we go. There we are. I'll see if I can make this magic happen again. There it is. So that's what I said at the beginning. That's that's our role, is increasing the contribution that design makes to the economy. So hopefully we've done a little bit of that today. We've shown you how design is important and the difference it's making, and hopefully start some interesting conversations. So we, and you are all part of Design Network North now, whether you like it or not. But my role is really to kind of facilitate that, and I'm very happy to do so. And so our role really is to kind of support the network, encourage collaboration, and we've seen a lot of that today. And every month at one of these events, there are interesting connections get made that I sometimes hear about. A lot of times I don't. So if you do meet someone, if you have met someone amazing today or at a previous event, do let me know, because we love to hear about it. It's also about giving assistance to companies as well. So if you want some help with something, then ask, please ask. And if we can't help, we can often find someone who can. It's about sharing knowledge, and we all learned something today, I'm sure. And it's also about helping to raise the profile of the importance of design, the profile of the North as being an amazing place that we all know about, but not everyone does. But also helping you raise your profile as well. So if that's something you want some help with, then do let me know. So this is where you've been this morning, learning about Subsea Robotics. Next month, we're going to be focusing on service design. So we've got someone who's talking about the digital side of designing digital services. And then we've also got somebody from the Rural Design Network who are working a lot with rural communities and looking at how to design services and things like that to make their lives more interesting. And a few other speakers that haven't been confirmed yet. But that should be a really good session. 11th of June, it's up for grabs. So if you've got an interesting story to share, or there's a topic you think we should cover, then do let me know. One thing I am wondering about, though, is that given that by then things might have changed and people might be starting to move back to offices, but hopefully not in the same way that they were a year ago, there's a lot of thinking going on and further thinking that needs to be going on. And I'm wondering if that is an interesting topic we should cover, given that at the time it'll be quite pertinent and it does need a bit of thought and a bit of design. So I'll share that when I email you all on Monday. But if you've got any strong feelings on that and you think we should cover it, then we'll do it. And also, we might even be back in Proto by then, or at least those of us who are happy to be. So I'm in discussions with Proto at the minute. However, we will still keep this kind of hybrid thing going on because we've learned so much and we've gained so much from all of this. So if you aren't within travelling distance of Gateshead or don't fancy the trip, don't worry, we'll still be online for those of you who do want to make that journey. There's lots of information on the Design Network North website. It's your website, so please do use it. There's space there for news stories. There's information on all the events. There's lots of stuff on there, so please do pay a visit if you want to know a bit more. If you don't know what we do, that's one of the ways you can find out. So designnetworknorth.org. A couple of things I'm going to mention. So this event has been sponsored by the Supply Chain Northeast program delivered by RTC. There's a team of specialists, and it's not just about supply chains. It's about kind of growing your business, getting into new markets, doing new things, diversifying. And there's a team there who can give you a lot of help and support with all of those things, helping you identify new opportunities. We've got issues around standards, skills. So again, I'll send information on that out to you on Monday, and please do get in touch with them if you think that might be useful. They've got a couple of events coming up. So there's one on objectives and key results for your business. So that's the 26th, which is what, week after next. Just a couple of hours there, again, online. We've got one later that week, reimagining through performance, productivity and digital transformation. So kind of working in a more digital way. And then there's a session on cybersecurity, understanding what cybersecurity is and what you do about it and how to manage the risks. So I think it's probably relevant to all of us. So there's some events to get yourself along to. Again, I'll share information on that next week. The other thing that I'm going to very quickly mention is well, it's not called Innovation Growth Services now, but that's what it is, offered by Innovate UK. It's now called Innovate UK Edge, and I'm one of the specialists delivering on that. We've got a team of 10 in the Northeast and similar numbers in the Northwest and in the Yorkshire area. Through that, if you're eligible, you can get 5, 7, 10 days worth of support from that broad team. So it's not just from an individual advisor. And they can help with anything to do with helping you be more innovative, whether that's market research, whether that's identifying suppliers, whether it's identifying technology, whether it's looking at IP, anything like that. So if that's of interest, again, do get in touch and we can connect you to the right people. And then there's another thing coming up next week, which is really, really good. It's a series of events that the KTN are hosting. I went to the first one a couple of weeks ago and it was fabulous. A couple of hours, a couple of speakers talking about a topic. I'm not sure where they got the idea from, but anyway, but the right sort of people, if you know what I mean. Lots of time for networking as well. I would highly recommend it. The next one is next week. I'm going to be there. be great to see you there as well. It's only an hour, so I'm sure you can spare the time. And then there's another 3, I think, over the next 3 months. Really worth going to if you're interested in anything to do with innovation, which I'm sure you are. And then just finally, some of you may have attended one of the Design Means Business conferences that we held a few years ago. Most of them were recorded and filmed, and they're all there for your viewing pleasure. So we have some fantastic speakers from Aston Martin, from Nokia, from Orange, who remembers Orange, from Motorola, and some local speakers as well. You just log in when you register, and then you get the login details, and you can watch them. It's kind of a mini TED, if you like. So definitely worth viewing those. And that's it from me. So a huge thank you to our speakers. A huge thank you to all of you for coming along. I've thoroughly enjoyed it. I'm hoping you have too. Hope to see you next month. Have a great weekend at the pub and possibly at the hairdressers as well.
Thanks, Terry. Great stuff.
Yeah, nice to meet everybody. Thanks a lot.
Thank you.
Yeah,
Thank you.
thanks, Terry, again. Brilliant.
Thanks. Cheers.
Thank you.
Thanks
Really
again,
good morning.
Terry.
Bye now.
Thank you. Bye, everybody.
Well done, Terry. Great event.
Thank you. Well, I didn't do very much.
It's been absolutely brilliant. I do appreciate everything.
Good. Thanks, Phil.
Thanks all. Thank you very much.
Bye.
Really interesting. Thank you. Bye.
Thanks, Dan. Cheers. Thanks, Mark. And Andrew, thank you for that. It was great.
Thanks, Terry. Yeah.
Yeah, thanks, Terry. That was great.